Hello students, I am Proto Chakraborty from Department of Geology, University of Delhi. Today our topic of discussion is actually the mechanism of primary migration. In an earlier text, I have already discussed that the accumulation of hydrocarbon in a trap where we get it, it does not form there. It forms in a fine grained source rock and then gets migrated, and we also have discussed that there is something called primary migration and the secondary migration. Now, today our aim is that what is the mechanism of primary migration, how we interpret that the primary migration, in which form the hydrocarbons they participate in the primary migration, what are the forcings that cause them to migrate, in which direction they will go, they will tend to migrate. So, all these things is the topic of discussion today. Once you go through this discussion, then you will be able to understand that what are the primary nature of the hydrocarbon that basically participate in the primary migration process. You will also be able to know that what are the merits and demerits of the different mechanisms that people have proposed as a mechanism of the primary migration. And also you will be able to know that this primary migration, how much it is related to the temperature, pressure, the porosity, the evolution of the sediment in terms of its original porosity, compaction. So, all these effects, how it affect the primary migration, and that help the initial movement of the hydrocarbon after its formation in a source rock, that you will be able to know. Now, coming on to the generalized idea that what really we will be discussing today. So, I introduce with the idea that any hydrocarbon that is formed from the organic matter or the kerogen. Now, kerogens are distributed randomly within a sediment that is deposited in a marine setting, and that dispersed kerogen through the action of temperature and pressure that evolve into the hydrocarbon. And that initial hydrocarbon that also remain dispersed within the sediment in the form of either ketones, the esters, the acids, these get dispersed within the sediment. Now, when we talk about the migration of this sediment of this hydrocarbon from the sediment, it is always considered that how really these molecules of hydrocarbon that overcome the pore throat condition of the sediment and then it gets accumulated at a certain place. So, challenge is very high. The reason is that originally the oil or the hydrocarbon molecule diameter or the size, they are considered larger than the available pore size where they get formed. So, what are the facilitator that basically allows it to move through the pore throat and then get accumulated, so that it can move either within the source rock or it can move from the source rock to the reservoir rock, that what we talk about as a primary migration. So, our aim is that to discuss what is the original form of the oil, at what form when it forms, that what was its original form. Number 2, what are the process by which this original form of hydrocarbon that participate in the movement. Number 3, that what are the force that basically allow it to move and then allow it to make the hydrocarbon accumulated together. And then what is the force or the preferable direction of their movement. So, all these are the topic of discussion in this module, what we consider that the processes involved in the primary migration. Now, as I have already discussed, that the main challenge is that number 1, the solubility of oil that is very low in water, and number 2, that the oil molecule, they have a higher size, that most of the hydrocarbon molecules, they have a higher size compared to the pore throat size that we get when the primary migration starts. So, that provoked people to give different kind of models that what can be the facilitator of the hydrocarbon movement in the initial stage of the primary migration. The first model that came into existence, that is, people started talking, there is a concept called Proto Petroleum. Now, what is Proto Petroleum? They are saying that the hydrocarbon molecules, they do not move in the like a petroleum or the oil molecule, but they exist in the form of esters, ketones, acids, and that they consider that the initial form of petroleum, what they call the Proto Petroleum. And what people started believing, that though the solubility of oil in water is very low, but the solubility of this Proto Petroleum, that is ester, ketone, acids, they are not very low in the water. So if in this form they get dissolved into the water and started moving, that can be a possible pathway by which the oil can start its initial movement after its initial formation. But the problem or the demerit in this model was that yes, okay, that these are the early forms of hydrocarbon or the oil, and they get dissolved in water, and this is how they move, but it could not be explained that how after movement that the hydrocarbon gets separated, or the initial protopetroleum components, they get separated from water. So people couldn't describe or defend that what is the separation model of this hydrocarbon from the water. So that's why this was not very agreed upon model by many of the workers. Now, one problem it is always there, that whatever we are talking about this initial movement and these are all, we are talking about the subsurface condition on which our control is very, very low. So if I want to give any model, what is the modeling of the subsurface when the kerosene that evolves into hydrocarbon, it started moving. So there is always different pros and cons, there is different logic and the counter logic. So all this goes on because it is very difficult to model or to observe the subsurface condition in direct. Now, once this protopetroleum model that was not very acceptable for many of the workers, then people started talking about the dissolution of hydrocarbon molecules into water. So this group of people, they started talking that the hydrocarbons get dissolved in water and water acts as a carrier, and that carrier takes the hydrocarbon from its initial stage of formation. Now what is then people started talking about, what is the level of solubility of hydrocarbon in water? The solubility, as we know, that the solubility of hydrocarbon in water, that is very, very low. And what we find that even at about 25 degrees centigrade, at STP, first of all at STP, the solubility of hydrocarbon molecules in water is very low. Even at 25 degrees centigrade, for alkanes or N-alkanes which has the carbon number more than 12, their solubility is extremely low. But if we have the carbon number of N-alkanes that is less than 12, there the solubility is little better. The aromatic compounds in comparison, they have a little better solubility at 25 degrees centigrade. But this solubility of N-alkanes that get considerably higher when you reach to the temperature of 150 degree. But that 150 degree solubility is also not enough for the to justify the kind of hydrocarbon accumulation, because when the experiment is done, what is the bulk oil solubility, it is found that the bulk oil solubility in water at about 150 degrees centigrade, that is still less than 150 ppb. So if the solubility of bulk oil, it is less than 150 ppb at 150 degrees centigrade, then we can easily identify that to produce this bulk amount of hydrocarbon and its accumulation in a large amount, that you require a large amount of abnormally high amount of water that is required to justify the kind of hydrocarbon reserves we get in different parts of the world. And that amount of water, it is very difficult to see to justify at that depth where the hydrocarbon. So people then started talking about, let us see that how much water can be available at what depth the hydrocarbon is formed. And when it is found that the hydrocarbon that is formed at a depth of about 4000 meter, where the temperature is about 60 to 150 degrees centigrade. So if you consider the normal geothermal gradient, that is about 25 degrees centigrade per kilometer, and then the hydrocarbon forms at about 90 to 100 degree, actually the oil window that is about 60 to 150 degree. So if we go for the at least to the 100 degree centigrade, you require about 4000 meter of depth of the burial for the hydrocarbon to form. And when we see that what is the porosity evolution of the sediments, and then we see that the sediments lose their porosity abnormally in the first 2000 meter of the burial. So most of the water what is liberated from the compaction of sediment in burial, that gets liberated in the initial or the top 2000 meter of burial, and your hydrocarbon that is formed at the 4000 meter. So that really is a problem, that where from we get that much of water that will cause the hydrocarbon to move. In fact, if I go to board and show you that what is the nature of the water expulsion curve, then we will see that the problem what lies in this model. So this is a diagram. You can see that here with respect to depth, the porosity of the sediment that is being explained by this diagram. Now if you see this diagram, that the depositional porosity of the most of the sandstones and the shale, that is very quite high. If I start with the depositional porosity of the normal sandstone, that is about 45 to 50%, whereas the depositional porosity of the mudstone that can go even up to more than 70%. So I start with about 40-45% porosity, and then with the burial and the compaction of the sediment, you can see that the porosity, it can go below 10% even at a depth of about 2000 meter. Now if we see that what is the temperature range within that the oil gets formed. If I have about the geothermal gradient that is about 25 degrees centigrade per kilometer, then the oil window that will start somewhere here where you attain the 60 degrees centigrade temperature, that is 25 degree per kilometer, then the 60 degrees centigrade is a little below than the 2000. Okay. And then you can go even up to 150 degrees centigrade, that is commonly what we find the oil window. So if we get a normal, if we consider the normal, the oil window, the oil production, it is about your 100, about 90 to 100 degrees centigrade, then by that time already the sediment has lost much of its porosity, and that's why the availability of water that will be very low. And this is basically the problem of this model, that where we get that much of water, that will cause the large scale the transport of the hydrocarbon from the system. So as I am discussing that the major problem of this model, that is the solubility of hydrocarbon or the oil hydrocarbon compounds in water. Now if the hydrocarbon compounds in water, they are not very soluble, and also that the other problem what I have discussed, that is the availability of water itself. So both the solubility is a issue, because the solubility being very low, you require a large amount of water that needs to be needs for the hydrocarbon to be transported, which is very difficult to get at that kind of depth, and also the issue of the very low solubility. So people then started thinking of some other model which can come out of this kind of problem. And then came the concept of the micellar solution. Now what is a micelle? What is a micelle? The micelle is a ordered aggregate of polar compound which has a hydrophilic and hydrophobic tendency. Now the outer surface of it, that is basically hydrophobic, and the inner surface of micelle is, it is the hydrophilic, and they are called the natural soap. Now what people have modeled is that kind of a micelle, it will be attached with water at its outer surface and with hydrocarbon in the lower surface, and based on that the micelles that will carry the hydrocarbon from the pore outside the pore through the pore throat, because it will be a facilitator, the micelles, and because they have a hydrophilic and hydrophobic tendency. So, the people started talking about that this will help in the transport or taking out the oil out of the pore through the pore throat, because that always remained a big issue, that how hydrocarbon or the oil that will come through that very narrow pore throat. Now, this was taken by large number of people that yes, a micelle is a good solution, that it can attach the oil and water together and acts as a carrier for the both. But the problem that started was that the amount of micelles that we find in the normal source rock situation, that is not very abundant, and we do not get the such abundant kind of micelles so which can account for the large scale accumulation of oil at different places of the globe. This is number one. And number two, in many cases the sheer size of the micelles, that is much larger than the pore throat what we visualize at a depth of more than 3000 meter. So, as I have discussed in my earlier figure also, that there is a large scale compaction in the initial stage of the burial, and once the initial stage of burial and the liberation of water that is gone, that the pores were very constricted, pore throats were very constricted, and in most cases we find that the micelles, the hydrocarbon molecules, the esters, their sizes are much larger than the pore throat that is available at that place. So, both these situation that basically caused the problem for the micellar solution. And then people started thinking, as I have already discussed, that the water that is available at different stages of this burial, which will help in this along with the micellar solution. So, if I draw this diagram, that what is the availability of water at different stages of burial, then you will more able to understand that what is the scarcity of water at that, and even to the micelle scarcity I have already discussed, and the water scarcity that is there at that depth, which creates a problem for the migration of the hydrocarbon. So, again I will go to board and I will try to explain you that. So, in this graph what is being attempted to show you the availability of water with respect to depth, Now, what you can see that, as I discussed earlier in the curve, that what is the pattern of porosity, and that how the porosity that evolves with depth. So, what will happen if you reduce the porosity, the pore water will be liberated. So, in the initial stage, if you see, the availability of water will be high, but within 2000 meter the availability of water will be low. This is a pattern of curve that, suppose here is your 2000 meter, this is about 3000 meter. So, you can see the availability of water drastically decreases at the porosity that drastically decreases. So, that reduction of porosity in the initial stage of burial up to 2000 meter allows a large amount of water to get liberated. So, the availability of water is very high. Otherwise, the availability of water is very low, except for a kick at a depth where you get again a kind of little more water availability. Now, what is the reason for this kick in the water availability? The reason is the clay minerals. These clay minerals that release the water at that higher depth, most important is the montmorillonite, which basically allows the availability of water at a deeper level, where So, this water availability definitely is very important for the hydrocarbon migration, because the surface water will not be available, but this water will be available. That the reason is that, and this water is available at a much higher depth, at a much more higher temperature condition, and nearly, if you see that what I drawn in my earlier diagram, that the 60 to 150, that is 60 degrees centigrade to 150 degrees centigrade, that is the oil window. So, this nearly coincide that the oil window when this water gets liberated. So, though this water does not have much role, but this water definitely will have a role during the migration of the hydrocarbon, that the primary migration of the hydrocarbon. Now, what this water is? This water is actually the lattice water that we get from the clay minerals. So, this lattice water, when the mineral starts breaking, the lattice water that gets released, that actually help in this process. Now, in the micellar theory, we have tried to tell you that what was the advantage and what was the disadvantage. So, there are some people who are the proponent and some are who are the critic, but it is also not a unanimously accepted model. Then people started talking about the other model. The model is, that is the gas input within the oil. When the hydrocarbon is done, then at the same time carbon dioxide and hydrogen gas also get produced. Now, this carbon dioxide and hydrogen gas, if it gets dissolved within the oil, what will be the net result? That the oil, the hydrocarbon molecules will get soiled, their viscosity, the interfacial tension, that will be reduced. So, the solubility of gas within the oil, that will increase the liquidity of the oil, and thereby it will help in the facilitate the migration of the oil. This is almost similar to the enhanced oil recovery, where carbon dioxide gas is pumped in a depleted reservoir to get the rest of the oil, the maximum recovery from the reservoir. So, that this also is considered by a large section, that the input of this gas, that is carbon dioxide or hydrogen, that will be helping in terms of the reducing the viscosity and the interfacial tension, and thereby helping in the migration, primary migration of the oil. The next model, what people talk about, that the migration as a continuous phase. This is something like the moving of wax through a small pore. We also call it Greasewick model. In that case, people talk about that there is a continuity of the hydrocarbon phase, and that basically allows it to move through the pore space. No role of the water solubility here, no role of the availability of water here. The major role here is that of capillary pressure and the interfacial tension. Now, we have to reduce the interfacial tension and overcome the capillary pressure, and then oil as a continuous phase will. The main problem in this model is that you have to have a oil wet situation, but most of the reservoir, they are in the water wet situation. And then if we want to move oil as a continuous phase, just like a movement of wax, melted wax through the pore space, in that case we have to have the wetness of the pore space by the oil, that is the oil wet, and that can only be achieved when the saturation level of oil that at least reach to a critical limit, that the water wet situation transforms into oil wet situation. So, that is the kind of situation that will cause the continuous movement of the oil from this system. Now, this model, though accepted by some, again got criticized by some, because the situation what I have talked about, that the reservoirs are mostly water wet, not the oil wet. Now, the other so it is also not fully accepted, this model. Now, the other model that people talk about, that is the diffusion. Now, what is diffusion? The diffusion is from the higher concentration to the lower concentration by diffusion. It is not a flow, but by a diffusion that the phase is moving. It can be true for a gas phase, but it cannot be true for a oil phase. So what we get is that we have discussed a large number of models. These models all have their own merit and demerit, and none of the models is sensu stricto capable of describing that how really the hydrocarbon starts moving, in what form it starts moving, and then how it moves within the source rock and then from the source rock to the reservoir rock. But there is a plethora of different models that is being available, and this plethora of the models that allows us to visualize that how complex the system is. And this complexity is the challenge of the primary migration modeling, and that is the theme of the discussion what I am talking about. Now, we have also discussed in our discussion, which I can summarize, is that what is the role of the compaction, what is the role of the solubility of hydrocarbon in water, what is the role of water in the migration, how much it is effective, which water is effective is the original superficial water which get released, the interstitial water get released because of compaction, or the water that is released because of the breaking of the clay mineral and the particularly monomodulonite. We also discussed the issue of the micelles and their role in the hydrocarbon movement and the demerits in their in that. We discussed the hydrocarbon moving as a continuous phase and how much it is possible, because you require a minimum saturation level to satisfy that kind of oil weight condition. So all these are the discussion that what we have done, that gives you the idea that the further studies in this direction is definitely needed to finally give a solution that what really promotes and provokes the primary migration of the hydrocarbon. I believe that you all have enjoyed this module of discussion, and this will encourage you for the further study in the literature which is already given in the e-text of this module. Thank you.